Hello and welcome to Friday STEAM with the Warren County Library System. My name is Sandy Roberts and I'm the Makerspace Coordinator for the Warren County Library. Each week on Fridays at 3 o'clock, I bring you a short science, technology, engineering, art, and math lesson. Today, we are talking about the solstice, specifically the winter solstice. The solstice is an important date. We have two solstices in the year. We have the autumnal, we have the spring. I'm getting myself all messed up because I'm thinking equinoxes. Right, so we have the winter solstice, which takes place in December, and then we have our summer solstice, which takes place in June. We also have the equinoxes, which we have in autumn and spring, and these mark our seasons. They're astronomical events. They're not just random dates. They're actually important things that scientists track and that people have tracked for thousands of years, so they knew things like when to plant their plants, when to harvest vegetables, when it was going to get cold, and fairly naturally, lots of different festivals and holidays built up around these important dates. Notably, for many of us that celebrate, Christmas is aligned with our winter solstice. So what is the solstice? Well, at the end of the day, it's the longest night of the year, okay? The most hours of darkness that we have over the course of the year. Its exact opposite, our summer solstice, is the longest day of the year, the most hours of light in the northern hemisphere. The autumnal or autumn equinox is when we have basically the same number of light and dark, same for the spring equinox, usually in March or April. So we use these to kind of break up the year. But they are based on the motion of our planet, okay? Sometimes people think that we have winter at a certain time because we're further from the sun, or we have summer at a certain time because we're closer to the sun. But the truth is, the sun's heat doesn't really radiate the 93 million miles to reach us here on Earth. But what does reach us is its light. And the way that light hits the planet is actually what gives us our seasons, for those of us that experience them in the southern or northern hemispheres. This is less if you're around the equator because you don't get as much of a difference. Why? Well, all right, I've got a bamboo skewer and some Play-Doh because we need to make a miniature Earth. So forgive me. Ooh, this is not great Play-Doh. This Play-Doh's been sitting around a little bit. So give me a moment to make ourselves an Earth here. I'm just making myself a little ball. You can do this at home if you want to explain it or if you want to explore these concepts yourself. Okay, just making my little Play-Doh Earth here. Sorry I didn't have any blue Play-Doh. I would have liked some blue Play-Doh. Would have looked a little more realistic. But, okay, here we go. There's our Earth. Now here's the thing. Our planet is not really just going around the universe or going around the sun straight up and down, as a perfect little ball like this. It's actually at a 23-degree angle. So it's on what we call, let's see if I can get this just right. It's on an axis. Okay, so it's tilted. All right, and that tilt is really important for causing our seasons. That tilt means that light is going to hit the northern part of the planet differently than it hits the southern part. I'm going to switch cameras to demonstrate. So, for example, if you were to take a flashlight, come on flashlight, and shine it down at the table, you can see I get a pretty nice little ball of light there, right? It's very concentrated, that light. Meanwhile, if I angle my flashlight, that light spreads. Okay, it's more diffuse is what we call that. So basically, depending how concentrated that light is, will determine how much that light and that radiation heats the ground or the air or the water that it's hitting. The more concentrated the light, the more warm it's going to be, the more heat it's going to generate. The more diffuse the light, the cooler it's going to be, the less heat it will generate. And that's a pretty complicated reason that we could get all into. But what you need to understand is that the light from the sun is what's really important. And that light from the sun hits our planet, bounces off of the water, gets absorbed by our water and our land, and bounces around in our atmosphere, and that generates the heat energy that keeps us toasty warm. It's not the actual heat from the sun. So in the summertime, if we have our planet and the light is hitting in a more concentrated fashion, it's going to be warm. If it's hitting in a more diffuse fashion, it's going to be cooler. And when you take into account, so let's see if I can keep this on camera for you, I'm going to break my bamboo skewer so I can get a little bit easier here. If I've got my tilted planet and my flashlight, okay, the sun is not going to hit all of it equally. It's going to hit the part that's jutting out, pointing towards the sun more, and the sun is going to be more concentrated on that part of the planet, whereas the light is going to be more diffuse over this part of the planet. Let me see if I can turn on my bigger flashlight, my bigger light here to make this a little easier. Here we go. Here's our sun for today. Okay? And you can see it a little bit easier with my planet. So the part of the Earth that's angled towards the sun, in this case our southern hemisphere, is going to experience summer with the more direct light. Can you still see it? Yeah. Whereas the northern part is tilted away from the sun, and it's going to experience winter. Change that tilt, and now the northern hemisphere is experiencing summer, and the southern hemisphere is experiencing winter. And it's just because of the concentration of that light. So why don't we have this happen, I don't know, every other week? Well, as that planet goes around the sun, that tilt is going to work a little bit differently. For example, here, everything's getting basically the same. And I'm trying to make sure that I can share this on. It's very tough to do this on camera. See if we can get this. So here, we basically are getting all the light hitting the two hemispheres the same, okay, because of the way that it's tilted. This would be an equinox coming around this way, okay? The northern hemisphere is going to be experiencing winter, while the southern hemisphere experiences summer. Coming around, okay, we've got another equinox here, and back around the sun, completing one complete orbit around the sun. Now we've got summer in the northern hemisphere and winter in the summer in the northern hemisphere and winter in the southern hemisphere. And that's really all that's happening. That's why we get the solstices. That's why the seasons change. It has to do with how the light is hitting our planet. So that's your little astronomy lesson for the day. So the solstice is a really exciting time. And there are a lot of different things that you can do. For example, I'm going to post in the comments right after I'm done simple instructions to make a sundial out of paper. And this will let you actually track time by the movement of the sun across our sky. It's not quite the same as the solstice, but it does give you an opportunity to think about how the sun is hitting. Or just go outside at different times of day and take a look at your shadow. It's kind of the opposite, the reverse of what I was just showing you with how the light is hitting. At noon, when the sun is most directly over us, right? That sun is directly over us. That's when you're going to see almost no shadow. But as the sun moves to an angle at the morning or in the evening, your shadow will draw out and out and out. And again, that's just because of the angle of the light hitting you. So that's one way that you can actually see your shadow change because of the same changes in angle to the sun, which blown up to the size of a solar system actually adjust our seasons. So that's why the winter solstice happens, and isn't that lovely? A A long night, of course, was pretty scary if you were an ancient people who didn't have fun things like electricity, which is why they celebrated this time of year and often celebrated with fire and light to remind them that the days were going to get longer and spring was going to come again, which is a pretty good reason for a celebration, if you ask me. All right, that is our Friday steam for today. I want you to go ahead and get yourself some Play-Doh or clay or heck, a Munchkin donut maybe, and share why we get the solstice, why we get seasons with somebody else. Because if you demonstrate what you've learned, it'll stick better. Okay? This is our last Friday steam for 2020. We're going to be on hiatus at the beginning of the year, but hopefully we'll be back again for summer with Friday steam. We have a lot of other great science and engineering activities, though. Take a look at Try This, engineering design on Wednesdays. We have Physics Quest on Fridays, and I've just added a new Science Action Club on Mondays. So we've got lots of fun activities that you can do with me over Zoom so we can keep on learning all summer, or I'm sorry, all winter. I'm all mixed up today. All winter long, and be hands-on and have some fun together. All right. Take care. Have a wonderful, wonderful holiday season. Enjoy your winter break if you have one. And I will see you in 2020. Bye.